Hello friends, today we are going to do very important section of mathematics, coordinate geometry. Coordinate geometry is very important ideas of mathematics which connects geometry and algebra through graphs, lines and curves. So today we are going to do some important portions of coordinate geometry like how to derive distance formula, how do we apply on certain problems and how to derive section formula as well as midpoint formula. So let's go on. Coordinate geometry. Okay, coordinate geometry. Today on this lesson we are going to do how to derive distance formula and how to derive section formula along with midpoint formula. So what is distance formula of any two given points? For example, 2 points, point A and point B, and the coordinates of point A is x1, y1, and the points of B is x2, y2. Now with these two given points, we can find the distance between A and B. We can find the distance between A and B using the formula, distance formula. So what is distance formula? Here AB is the distance, and what is the formula? Square root of x2 minus x1 whole square plus y2 minus y1 whole square. Using this formula, you can find the distance of any 2 points if their coordinates are given. So how do we derive this formula? Today in this lesson we are going to do how to derive this distance formula. So now we are deriving this formula. We will derive this formula. Distance AB is equal to root over x2 minus x1 whole square plus y2 minus y1 whole square. Friends, this coordinate geometry is very important section of mathematics, and as I told you, it is this coordinate geometry that connects algebra and geometry through graphs, lines and curves. And the credit for this coordinate geometry goes to René Descartes, who was born in 1596 and later died in 1650. So to give honor to him. So this coordinate geometry is often named as Cartesian Coordinate, and the plane where we draw the lines, any figures are called Cartesian Coordinate plane. So let's go on deriving the distance formula. So let's make any Cartesian plane. On Cartesian plane, let's draw a line. Suppose this is y-axis. Sorry, this is y-axis and this is x-axis. As you know in the graph, this is the basics of the graphs. This, let's name it x-o, x dash, and this is y-o, y dash. So friends, this is the origin where x-axis and y-axis meets, and on this plane let's make a 2 points, point A and point B. Suppose the coordinates of A is given as x1, y1, and the coordinates of B is given as x2, y2. Now the coordinates of A and B are given. You have to find the distance of A and B. So you need to find this distance. You need to find this distance AB. So how do we find it? Now see the diagram. Given 2 points A, x1, yn, and B, x2, y2. So you need to find the distance AB. How do you derive it now? Now from here, from this point A, draw perpendicular on x-axis. On x-axis, how do you draw? On x-axis, and you can name it as C. Similarly, from point B, draw a perpendicular line on x-axis. Now, you can name it as D, point D. Now, from point A, draw a perpendicular line on BD, that is on y-axis from A. You can name it as E. Now you can see in the diagram, this triangle AEB is right angle triangle. Triangle AEB is right angle triangle. So, according to Pythagoras theorem, in order to find the distance AB, you should know this perpendicular BE and base AE. So, how do we find it? Now, see here. What is the distance of AC? The distance of AC is y1. The distance of AC is y1. And what is the distance of OC? What is the distance of OC? x1. Similarly, and what is the distance of OD? The distance of OD is x2. And similarly, what is the distance of BD here? The distance of BD here is y2. The distance BD is y2. Now, what is the distance between CD? How can you calculate it? How can you calculate it? You can calculate like this. So how do you calculate CD? CD equals to, now see the diagram, what is the value of, what is the distance of CD, how you calculate it? OD minus OC. From this line segment OD, if you remove OC, then you are getting the value of CD. So CD is equal to, how you can find the value of CD? CD is the whole line OD minus OC. OD minus OC equals to, what is OD? What is the length of OD? x2. And what is the length of OC? x1. x1. So, now this line, we already have drawn this line AE parallel to CD. So, this AE is parallel to CD, therefore, now CD, this CD and AE are parallel, and we can write AE is equal to CD. AE is equal to CD, which is equal to, what we have got it here, x2 minus x1. Let me remind you, this AE is drawn perpendicular on this line BD, as well as this AE is parallel to CD. So we got this value of AE. Now how can we find the value of BE? See the line segment B and D. From this line segment BD, if you remove BE, then you can get the length of ED. Sorry. From this line segment BD, if you remove the length of ED, then you can get the value of BE. So how can you get the value of BE? This value is already known. How it is known? AC is y1, therefore ED is also how much? y1. So the value of this is y1. Now, therefore, we need to find the value of BE. How do you find the value of BE? BE equals to, in order to get the value of BE, from this line segment, if you delete ED, then you can get the value of BE. So BE is equal to how much? BD minus, what is this? ED is equal to, now what is the value of BD? You can see the value of BD is y2. And what is the value of ED? The value of ED is y1. So we have got the value of this CD as x2 minus x1, and we got the value of B as y2 minus y1. Now See this triangle? This triangle AED is a right angle triangle. AED is a right angled triangle. AED is a right angle triangle. So applying Pythagoras theorem. Applying Pythagoras theorem, hypotenuse square is equal to perpendicular square plus base square. You can find the value of. Now what is hypotenuse here? AB. Perpendicular BE and the base is AE. So how do you apply it? Now hypotenuse here is AB square is equal to perpendicular is BE. BE square plus, and what is base? AE. AE square. Now let's put into the value. AB square equals to BE. What is the value of BE that we already got? Y2, the value of BE is Y2 minus Y1. Y2 minus Y1 whole square plus, and what is the value of AE? What is the value of AE? We already found it out. The value of AE is x2 minus x1. X2 minus x1 whole square. Now remove this square root. Therefore AB equals to, we have root over y2 minus y1 whole square plus x2 minus x1 whole square. So now AB is the distance that we are deriving here, we are finding here. So we can write, therefore the distance formula, AB is the distance. AB is how much? Arrange it into order. X2 minus x1 whole square plus y2 minus y1 whole square. So this is the formula that you can apply on various types of problems. So this way we have derived the formula, distance formula of any 2 points. So this is the formula. AB is equal to root over x2 minus x1 plus y2 minus y1 whole square. So this is the formula that you should remember, and let's do some example. How do we apply it? So this is important, very important formula. Now let's apply this formula on certain problem. Okay, now let's apply the formula. Find the distance between 2 points. Find the distance between 2 points. 2 points A. For example, let's take it A as minus 312 and B, let's take it as 3 5. Now applying that formula, find the distance between 2 points A minus 312 and B 3 5. Now already coordinates are given, A and B. You need to use the formula to find out. So what is the coordinates of A? Minus 312. And what is the coordinates of B? 3 5. Now using that formula, you need to find the distance between these 2 points. So how do you find the distance? As I told you, x1, y1, x2, y2 are given. So according to formula, AB is equal, what is the formula? As we have derived before, x2 minus x1 whole square plus y2 minus y1 whole square. This is the formula. So apply it. When we apply it, this is x1, x2, y1, y2. Now x2 minus x1 whole square. What is the value of x2? 3 minus x1. x1 is how much? Minus 3. And plus y2 minus y1. What is the value of y2? 5. y1? 12. whole square equals to, now 3 plus 3 here whole square plus, now here 5 minus 12 minus 7 whole square equals to 3 plus 3 6 and square 36 plus negative into negative is positive, so it is 49. So when you simplify it, AB equals to how much? Is equal to root over 585. So we got the value of AB is equal to root over 85. So the distance between AB is root 85. This is the answer. Though this is just the simple application of this formula to find the distance between 2 points where their coordinates are given. So now you can practice more of this type of problems. Now we go on to section formula. What is section formula? Section formula is a formula to determine the points which divide a line segment into two segments, into two portions in a given ratio. For example, this point A and B is a two line segment with coordinates x1 comma y1 and x2 comma y2. This is a line segment, and any point divide its, for example, point D. D divides in the ratio m is to n. Let's suppose it as m is to n. Now this point D divides this line segment AB in the ratio m is to n. In the ratio m is to n. So let's suppose this coordinates is x, y. Coordinates of the point which divides the line segment in the ratio m is to n is xy. So how do we find it? How do we find the points, the coordinates of this point? So the formula, as I have told you, the formula is like this. X, how do you find x? M x2 plus n x1 m plus n. Similarly, y m y2 plus n y1 upon m plus n. So we will derive this formula now. This is called section formula. So we are going to derive this formula. Again, we will draw x-axis and y-axis on a Cartesian coordinate plane. For example, this is y-axis, this is x-axis, x, o, x dash, y, o, y dash. Now, let's name this point P, Q, A, B, anything. This is point here, P, and this is point here, Q. And the coordinates of P is x1 comma y1, here x2 comma y2. And this is a, we join these 2 points. Now let's suppose this line PQ is divided by a point A. Suppose this line segment PQ is divided by point A in the ratio m is to n. And it's so we have to find out the coordinates of A. Suppose the coordinates of A is xy. So how do you find the value of this point which divides this line segment in the ratio m is to n? So again, what we do, from this point P, draw perpendicular on x-axis. You can name it anything, PQR. You can name it R. Similarly, from this point Q, from this point A also, Q also, draw perpendicular from A first. you can name it S. Similarly, from this Q, you draw perpendicular on x-axis. You can name it as T. Now, from this P, draw perpendicular on AS or parallel to RS. From this point P, draw a line parallel to RS or parallel to x-axis, you can say. Similarly, from this point A, draw a line parallel to x-axis. You can name it as U. And from here also you can draw a line parallel to x-axis. You can name it as V. Now we need to find the coordinates of A. First of all, to find the coordinates of A, we need to find the values of some points, find out the coordinates of some points. Now, this point P, the coordinates is xy. So what is the distance OR? How much is OR? The distance OR is x1. This distance is x1. Similarly, what is this distance OS? What is the distance of OS? It is. What is the distance of OS? It is x. And what is the distance of OT? The distance of OT is x2. The distance of OT is x2. The distance of OT is x2. Similarly, now, what is the distance of PR? What is the distance of PR? y1. And what is the distance of ASY? Similarly, what is the distance of QT? y2. Now, we need to find what is the distance RS equal to? How do you find it? RS equals to OS minus OR. From this line segment OS, if you delete OR, you will get the value of RS. And the value of RS is equivalent to PU. Similarly here, in order to get the value of AU, what you do? So what is the distance AS? The distance AS is Y. And what is the value of US? US is equivalent to PR. So the value of US is Y1. So when you delete this portion from this line segment AS, when you delete this portion US, you will get the value of AU. So let's do it. Now here, PU is equal to RS. And how do you get the value of RS? From this OS, you need to delete OR. OS minus OR is equal to, what is OS? What is the distance of OS? X minus, and what is the distance of OR? X1. So you got the value of PU. And next, how do you find this AU? How do you find this AU? As I told you, from this line segment AS, you have to deduct this value US. Then you will get the value of AU. So how do you do it? AU is equal to AS minus US. Equals to, what is the value of AS? The value of AS is Y. And what is the value of US? Since PR, this is parallel, this line is parallel, therefore this PR is equal to US. So the value of PR is Y1, definitely US will be Y1. So you got this value. You got the value of this and you got the value of this. PU is equal to RS, OS minus OR is equal to X minus X1. Similarly, AU is equal to AS minus US, Y minus Y1. Now, similarly, you need to get the value of this and this as well. Similarly, you need to find this value as well. Now, how do you find the value of this one? Now, for example, the whole distance QT is y2, and what is the distance of this one? Vt. What is the distance Vt? This distance Vt is equivalent to AS. How? Because this line AV is drawn parallel on this line QT. So how do you find it? What is the value of AS? As you know, the value of AS is y. So how do you find it? The value of QV? QV is equal to the line segment QT minus this portion VT equals to, what is QT here? The distance between QT is y2 minus, and what is VT? This distance VT is equivalent to AS, and as we know, the value of AS is y. So y2 minus y. And similarly, you can find the value of AB. How do you find the value of AB? Now, first of all, the distance between OT, is how much? X2. And from this line segment OT, if you delete this section OS, then you can get the value of ST, which is equivalent to AB. So how do you do it? AB is equivalent to, this AB is equivalent to ST. And how do you derive the value of ST? From this whole line segment OT minus, you need to delete this portion. What is this portion? OS. So what is the value of OT here? What is the value of OT? X2. The value of OT is X2 minus, and what is the value of OS? X. So this way we got the value of QV as well as AB. So X minus X1, the value of PU, and AU is Y minus Y1, QV is Y2 minus Y, and AV is X2 minus X OT. So we got the value of this all 4 points. So now see this triangle properly. This triangle PUA and triangle ABQ. They are, check it, PUA and AVQ. They are similar triangles. So in similar triangles, corresponding sides are proportional. So here, triangles PUA and what is another triangle? AVQ. AVQ are similar triangles. So if triangles are similar, then their corresponding sides are proportional. So what are the corresponding sides here now? PA upon AQ equals to, now another corresponding sides, PU upon AV. PU upon AV. Another corresponding sides, AU upon QV. These are the basic properties of similar triangles. Now these are corresponding sides of similar triangles. They are in proportion. So let's put in the value PA. What is the value of PA? According to this, we have supposed N. And AQ, N equals to PU. So how much we got the value for PU is X minus X1. And how much we get for AV? AV, X2 minus X. Similarly, what is the value of AU? Y minus Y1. And what is the value of QV? Y2 minus Y. Let's put the value of PA, AQ, PU, AV, AU, QB, which we already derived from this diagram. So now we don't need this. These are important portions. So we don't need this now. We will derive the formula. Now from this, take these two first and again take these two as second. Taking the first portion, how much? M by N equals to x minus x1 by x2 minus x. First of all, we'll take this. Now cross multiply. When you cross multiply, M within bracket x2 minus x equals to N within bracket x minus x1. Now it's just a matter of simplification, or mx2 minus mx equals to nx minus nx1. Now, or mx2, when this minus nx1 comes here, plus nx1 equals to minus mnx. When go to the right hand side, it becomes mx plus nx. Now, this portion, what is common here? X is common here. So you write it on the left side, x common within bracket, n plus n equals to, now here nothing is common. So mx2 plus nx1. Now you got the value of x, or x is equal to, so what is the value of mx2 plus nx1 by m plus n. So here we got the value of x, as I told you in the formula, mx2 plus nx1, m plus n. So here we got the value of x. Similarly, now take this first and this last part to derive the value of y. So what we do similarly, okay, let's delete this diagram now. We don't need this. Now let's take these two portions. Taking m by n equals to y minus y1 divided by y2 minus, this should be qv, it should be y. Now again cross multiply, m into y2 minus y, similarly n y minus y1. When you cross multiply, my2 minus my is equal to ny minus ny1. Now, or anything common here? Nothing is common here, so you need to arrange it. So my2 minus ny comes to the left hand side, plus ny1 equals to minus my. When go to the right hand side, it is plus my, and plus ny is already there. Now here what is common? Y within bracket m plus n equals to my2 plus ny1. Now y equals to my2 plus ny1 divided by m plus n. So you got the value of y also. So we got the value of x, we got the value of y. Therefore, this is the section formula. Therefore, section formula. Section formula is how much? What is the, put in the value of x. What is the value of x? mx2 plus nx1 divided by m plus n. Similarly, we got the value of y2. my2 plus ny1 divided by m plus n. This is the value of a point which divides a line segment into two portions with certain given ratio. So this is the section formula. This is very important to remember. So we will apply this formula on simple problem. So let's do one problem. So this is the formula that you need to remember. Now we will solve one simple problem in order to know how we apply this formula. Okay, I'll read out one problem. So we'll try this formula. Find the point, this question, find the point which divide. Find the point which divide the line segment joining the points, which divide the line segment joining the points minus 1, 2 and 4, 5. Minus 1, 2 and 4, 5 internally in the ratio 2:3. Internally in the ratio 2:3. So this is the application of section formula. Find the point which divide the line segment joining the points minus 1, 2 and 4, 5 internally in the ratio 2:3. Now just to understand the problem, suppose a line segment is given A, B, and the coordinate points of A is minus 1, 2, and the coordinates of B is 4, 5, and it divides somewhere here, and in the ratio 2:3. 2:3. So you need to find out the coordinates of this point D. So simple, the formula, let x, y be the coordinates. Coordinates of the point. Let x be the coordinates of the point which divides the line segment AB in the ratio 2:3. Now we need to find the value of x and y. So as we told, so apply the formula, the section formula. X is equal to m2x1 plus mx2 plus nx1 m plus n. Similarly, what is the value of y? my2 plus ny1 divided by n plus n. Now you can apply. So this is x1 y1, x2 y2, and this need to find xy. We have already supposed here. So what is the value of x is equal to, now mx2. What is m? 2. And x2. What is x2 here? 4. Plus nx1. What is n here? 3. And what is x1 here? Minus 1. m plus n. 2 plus 3. So 8 minus 3 and 5 equals to 5 by 5, 1. So the value of x is 1. Similarly, using this formula, you can find the value of y. So y is equal, what is the formula? This is the formula I have already written. So y equals to m. Again, m is 2 here, and y2. What is y2 here? 5. N y1. What is n? 3. y1 is 2. m plus n equals to m plus n, 2 plus 3, 16 by 5. So what is the points of the point which divide this line segment in the ratio 2:3? So we got the value of x 1, we got the value of y 16. So therefore What is the point? Therefore, you can write the point which divide the line segment joining the points minus 1, 2, and 4, 5 internally in the ratio 2:3 is how much? What is the value of x? 1, comma, and what is the value of y? 16/5. This is the points. So we got this point. This is just the simple application on simple problem. Now as we learned what is section formula, as we learned how to derive this section formula, and now we go on to the next step, which is very simple. I think 1 or 2 steps. That is midpoint formula. Using this formula only, we can we can derive midpoint formula. So what is midpoint formula? Midpoint formula, for example, any 2 points is given. Any 2 points A and any points B is given. The coordinates of A is x1, y1, and the coordinates of B is x2, y2. So you have to find the midpoint which divides this line segment into 2 equal parts. For example, this is the point M, and suppose it as xy. Now this M is the point which divides this line segment AB into 2 equal parts, AM and MB. So there are 2 ways of deriving this formula. One is using this AM and MB, or when you put the values of these 2 equal ratio into this section formula, you will get the midpoint formula. Okay, the formula for midpoint formula is, I will give you here, x1 plus x2 divided by 2, y1 plus y2 divided by 2. This is the midpoint formula. Now we will derive it. Now as you know, what is the section formula? Now since this point divide these 2 into equal parts, so this part and this part are always equal, meaning this ratio is equal, 1:1, or m is n 1:1 equal. So here m is to n, the ratio is how much? Equal. M is to n 1:1, they are equal. So therefore in section formula, what is the section formula? The section formula was like this: x is equal to m x2 plus n x1 m plus n. Now since this point divide it equally, so the ratio you can take it as 1:1. So is equal to, you can take 1 x2 plus 1 x1. We are replacing the value of n by 1, m plus 1, m plus n, sorry. So x1 into 1 is x1 plus x2 into 1 is x2 divided by 2. So this way we got the value of x. Similarly we can get the value of y also. So y is equal to, according to section formula, the value of y is my2 plus ny1 m plus n. Now putting the value of m1 y2 plus 1 y1 divided by n plus n is 1 plus 1 equals to y1 is y1 plus y2 divided by 1 plus 1 is 2. So we got the value of y also. Therefore what is midpoint formula? Midpoint formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2. This is midpoint formula. So we will solve one simple problems on the application of midpoint formula. Then in the next session we will be doing some advanced problems on this coordinate geometry and some more sections of coordinate geometry in details. So the formula: find the midpoint of the line segment joining the -3, and 5, 3. Okay, find the midpoint of the line segment joining the points -3, 3 and 5, 3. -3, 3 and 5, 3. We have to find the midpoints of the line segment which join the 2 points minus 3 3 and 5 3. Just to understand the problem, the 2 points are here. A is minus 3 3 and B is 5 3, and we have to find out the midpoints x y. We have to find the point, determine the point, the value of point M, which is dividing this line segment, and the coordinates of A is given and the coordinates of B is given. So put in the value of Midpoint formula. X is equal to x1 plus x2 upon 2. What is x1? Minus 3 plus x2 5 upon 2 equals to 2 by 2 equals to 1. Similarly, the formula of y is y1 plus y2. 3 plus 5 divided by 2 equals to 8 upon 2, which is equal to 4. Therefore, what is the midpoint, what is the points, what is the coordinates of the point that divide these two line segment as one line segment AB? So you got the point. Therefore, x is 1, 4 is the point which divides the line segment AB. Answer. So friend, this we have done the basics of coordinate geometry. In the next lesson we will do some more advanced problems and some more details in coordinate geometry. Thank you very much. Thanks.